Hello, this is part of my video series on basic statistics. This should enhance your application of statistical knowledge or preparation for statistical exam. You might want to pause the video to study the slide for adequate understanding of the concept. Today we'll be looking at confidence interval, and to do this we'll look at an example. So basically this is confidence interval for population variance. In previous videos we have looked at confidence interval for population mean, confidence interval for population proportion, and now we are looking at population confidence interval for population variance. X is a random variable with a normal distribution. A sample of size n equals to 21 resulted in sum of the samples to be 412.1, and the sum of the squares of all these values is 10,456.7. So we want to find the point estimate of the population variance and construct a 95% confidence interval for the population variance and standard deviation. So the first thing to do is to list what has been given in the problem, and we have the sample size, the sum of all the population, the sum of all the values in the sample, and the sum of the squares of the samples is also given in the question. So the degree of freedom therefore would be the sample size minus 1, which is 20. Then we can from the question we're given the confidence level as 95%. So therefore we can compute our significance level alpha to be 0.05. So now we can calculate the sample mean, which is the sum of the sample over the number of sample. That gives us 19.624. And then we can also compute the sample variance, which is the sum of the square minus the uh, sum of the sample over n all squared. That gives us 118.49. Therefore, the point estimate for the standard deviation will be square root of the um, sample variance, which is 10.89. So to construct the confidence interval for the variance, since we know that for a normally distributed population, the estimate n minus 1 over the variance, the population variance multiplied by the sample variance follows a chi-square distribution with n minus 1 degree of freedom. So therefore, we can construct our confidence interval using the boxed formula. And if we substitute the values, we can therefore we can get the critical value from the chi-square table. So the chi-square is 0.025, comma 20 is equal to 34.170, and the chi-square is 0.975, which is 1 minus alpha, comma 20 is 9.597. So therefore, to construct the confidence interval given in this box formula, we n minus 1 multiplied by s square divided by the chi-square alpha over 2, comma degrees of freedom will give us the lower limit, and we'll do same for upper limit. So if we substitute the values that we have computed, 20 into bracket 118, the sample variance divided by the population variance, this will give us 69.32 for lower limit and 246.87 for upper limit. Therefore, our confidence interval is 69.32, 246.87. By interpretation, we can also do the same for confidence interval for standard deviation, and that is by taking square root of the variance, and that means that our confidence interval for standard deviation is 8.33 and standard deviation 15.71. By interpretation, we are 95% confident that the true population variance lies between 69.32 and 246.87, and therefore the standard deviation also lies between 8.33 and 15.71. I hope you find this video helpful. If it is, like, share and subscribe to the channel for more videos, and you can make your comments in the comment section. Thank you.